Morning, everyone.
Good morning.
All right, just making sure everyone's still awake. So just quickly by way of introduction, my name is Krishna. You probably have never heard of me. I'm new to the community, been around with Cloudera for about a year. And you probably won't hear of me. I'm the guy behind the scenes that helps our team figure out what we want to do. At Cloudera, I'm responsible for operational databases. So that's HBase, that's Phoenix, that's Kudu, and then also now responsible for replication-related things at Cloudera. As a product manager, on a day-to-day basis, what we get to do is say, hey guys, wouldn't it be great if we did this over the next 3 months? And eventually it's, hey guys, wouldn't it be great if we did this over the next year? Every once in a while, we get to sit and pontificate. What should we do over the next 10 years? And today's presentation is a lot about what we're going to be doing over the next 10 years as Cloudera, with a little bit of focus on what are we going to do over the next 2 years. If you thought you were getting a 2-year roadmap, see me separately, and we can have a more detailed conversation. So whenever you go and pontificate about what you want to do, it helps if you start with where are you today. Did you realize HBase is the number 17 DBMS by popularity, but number 5 by revenue? Popularity is a really fun thing. It's actually really easy to get this rank. If you ever go to DB Engines, they actually look and go through all the social media activity relating to all of the different open source database systems, and they put a nice, neat ranking. Number 1 through 5 are actually really easy to guess. They're the multi-billion-dollar players. After that, it gets interesting because the popularity doesn't quite align with the revenue. So even though we're number 17, where HBase exists for our users, because of a lot of work that you guys have done, but also because of you, is that it's sticky and it's grown over time. And that's a great base for us to continue to build on as we think about where do we want to be over the next decade. It supports NoSQL, SQL, geospatial, graph, time series, key value, ... HBase doesn't support any of those things other than the first one. And this is the beauty of the open source world. HBase, for purity, is a data store. But a lot of other projects exist that sit on top of HBase. Phoenix for SQL, GeoMesa for geospatial, Janus Graph for graph, etc., etc. And when we think about where we are today, we can think narrowly in this is where HBase is, or we can think of what is the DBMS that we're building. And then it supports a very large ecosystem. NiFi, Kafka, Scoop, Hive. This is a very, very long list. Part of it comes from the fact that HBase is one of the early members of the Hadoop ecosystem. And part of it is because there has been a consistent focus on making sure that we actually are integrated with every aspect of the ecosystem. And so when a customer comes or when a user comes and says, hey, can I use HBase with X? The answer is usually yes. Have you thought about this? And lastly, and you've heard from some of these companies already, HBase is sold by a bunch of different vendors. I'm from Cloudera, so obviously we're number 1 here on this list. But IBM is. We heard from Microsoft earlier. Amazon sells it as part of EMR. Teradata sells it as part of one of their appliances. So does Oracle as part of their big data appliance. It's something that's sold by a lot of different vendors. And then what have our customers done with it? What have you done with it? This is the most fun thing to talk about on this entire deck. Operating ML and AI to revolutionize many different verticals. And it's easy to say that as it's an anonymous thing. But to cite a couple of examples, if you go into any hospital in the US, the care that you receive depends on HBase. There are certain diseases where the sensors that you get hooked up to send data to one of our customers who in real time does a diagnosis and says, you're likely to get this problem. And by the way, if the doctor doesn't finalize that diagnosis and give you treatment, you may die. And that period to diagnose is 6 hours. Now, this is not an everyday cold or flu type of thing. But if that didn't happen, thousands of people that survive today simply wouldn't. Public utilities. we're going down this path of smart meter rollouts in this country and in other countries around the world. Well, where does that data land? A couple of big public utilities chose HBase to power that collection of data. But there are a lot of different platforms that can write IoT. Is that what makes HBase interesting here? No. It's what they chose to do with it once it landed. They're running algorithms to do machine learning. And then doing that, using that to go and figure out, well, where do we need to do maintenance? But it's not a person at a keyboard running this query and then deciding, hey, John, can you go and fix that person's smart meter at address X? That dispatch is automated. By the way, it's not just about the smart meter, but the entire distribution network and doing preventive maintenance across it. There are many, many such examples that I could give. Similarly, web content was one of the things we started earlier on, and something a lot of customers have done. Not a lot to say about it other than it just works for most of our customers. And if it works, they're probably not even touching HBase once it's set up. Years later, they'll be like, I rebooted it 8 months ago and now I'm having problems. It's rock solid. Because of the origins of HBase coming out of the Hadoop ecosystem, and Hadoop being known as something for data warehousing in general, HBase is used for big data analytics, but it's got both operational and analytic use cases. People use it to do things like risk analysis to understand, hey, what's going on with my customer set? Am I likely to be defrauded? Are there some things here that shouldn't be? Do we need to go have someone go look at it? It's the offline use case. But then the online use case is, as these things get mature and these implementations get accepted, how about we just tell the person in the front end, accept or reject with a likelihood? Kind of some of the scary things we hear about AI are already being implemented behind the scenes. And hopefully to the effect of something that's positive. That home mortgage that you wanted, wouldn't it be nice if it got approved a little bit faster or a lot faster? Those are the type of risk type of things that HBase is being used for. And then it is acting as a resilient store of record. I never thought that HBase would be used specifically as a store of record with no other reason to be there, as a plain old key value pair. But I found out some of our customers are doing that as well. One customer I met has a whole bunch of log data that's coming from a set of equipment that they create. And all they do is write that log data as a tar file, as a gzip tar file onto HBase with a timestamp. Now they've got a whole bunch of this, like, well, if I want to do analytics, what should I do? Well, maybe I'll just unzip it onto another store and write it there. And then I'll go analyze it on that platform. So when we go through these type of use cases, the question comes to, why did we end up doing all of these different things? And the reason for that is all of you decided you wanted to solve problem X, and this platform made sense. Along the way, certain use cases people felt they could do better, and they forked off separate projects. And that diverted the community a little bit for many different reasons. Sometimes we got into discussions around what's the borderline, where do we draw a line of what this thing is versus the next thing is, and that resulted in some projects forking off and doing other things, and then interacting well with each other, or in some cases, not so well with each other. But given all of these use cases and the breadth of everything that HBase is used for, how do we focus to drive acceleration? Because until we drive acceleration, we can't grow as a community and can't grow up either from number 5 to number 4 or from number 17 to number 10. And so we have to focus. And as Cloudera, we've made a choice as to focus, which we'll talk about. But as a community, we also need to choose to focus and say, hey, we're going to go deep in specific areas, and we're going to go broad in others. And that's how we're going to push this platform forward over the next decade. So more of the recap. So what's changed since HBase began? This graph is something that probably stopped at the exabyte scale 10 years ago. Now I've talked to a customer that talks in 2-digit exabytes as the amount of data that they store. They're talking about, hey, I want to offload petabytes onto HBase. I have another customer that stores north of 2 or 3 petabytes in a single HBase instance. A third customer, while not in a single cluster, stores 70 petabytes of data in HBase. These are large numbers, but we also have a number of customers that serve small amounts of data in HBase. I've talked to customers saying, hey, I only have 30 terabytes of data. Is HBase the right platform for me? Even had a customer that was saying, I have a couple of gigabytes of data. Should I be considering HBase given it's already standing? So we've got to look at this thing, this curve, and say, yes, big data is getting bigger. But does that mean we forget about all the people and all the use cases that are on the bottom left of this, or do we just focus on the right-hand side? And the problems for the two of them are very, very different in nature. The other thing that's changed is what is considered an acceptable trade-off. 10 years ago, no one would have considered trading off agility versus ownership. I own it, it's in my data center, it's running there, therefore I am agile. Today, Microsoft can run it on HD Insight. No problem, I don't need to own this thing. Salesforce can, in fact, own all my CRM data. I don't need to own that either. There were plenty of sales ops people that would have said a decade ago or 2 decades ago over my dead body on that one. But that's where we are today. That's a trade-off people are willing to make. Second one is simplicity versus control. At the start of any technology adoption curve, every experienced person says, I need control because I don't trust the technology. As the technology matures, people are willing to say, hey, it's okay, I don't need as much control. I'm willing to accept this. And I'm willing to let it make some decisions for me. But then when you look across customer bases and across adoption curves, the early adopters are the first ones that want control. They're also the first ones that are willing to accept simplicity. But when you go into mainstream adoption, most of those folks don't care about the control. They care about job security, and if control gets them that, then sure. But if it's too complex, they're just going to run away and go look at the next thing, because we're one of hundreds of databases that are around. And so what they want is simplicity. Yes, give me control over where my data is. Give me control in terms of how to optimize it, but don't make it so overwhelming that I can't understand it. This one, everyone is familiar with. Infrastructure as code. The cloud providers in public cloud have provided it to us, but VMware has given it to us on-prem as well. So have other trends, other movements like OpenShift. And so we need to react to that. We can do auto-sharding, great, but what happens when we need a new region server or a new node or a region server falls? If we have enough capacity, that works. But if we don't, then someone's got to step in and stand up a server. Go deploy HBase to it, just so then the data movement can happen on its own. That's not quite an automated infrastructure as code experience. Wouldn't it be great if an HBase server fell down and we didn't even wake up, no alarms went? It didn't matter because another one came up, HBase was deployed, your regions moved to it. In fact, you had zero blip in capacity. You had zero change in capacity despite an outage, except for the blip of the period when the node was down and coming back up. To take it a little bit further, as your traffic goes and your queries peak and trough, should your HBase scale? That means nodes have to come up, nodes have to come down. That's the world we're now living in. That's the expectation that our customers are having of us. They want that experience that they're getting in the cloud to every single application that they have. It's always fun to use a Gartner term. HTAP is a Gartner term. It's not something I've heard from 3 customers. I've heard it from 1 who happens to read Gartner. It stands for Hybrid Transactional Analytical Processing. What they're basically saying is the world started with Oracle, with OLTP systems, and traditional data warehousing systems like Teradata on the other side. And they had very different demands on time from customers and capabilities. We're now at a far enough on the maturity curve where these two things need to come together. It's not good enough to have data warehousing saying, hey, I can do this offline thing and I'll give you an answer an hour from now. I want the answer now. And in fact, I don't even want a human involved. Just do the action. Instead of doing analytics on how effective my marketing is so I can change my messaging tomorrow, let's just change the targeting dynamically. Those are the type of things that HTAP systems promise. Now, I say it's a promise, and it's fun when you use Gartner terms from Gartner, because they're forecasting what's going to happen over the next couple of years. And so we're now seeing this. As we look at what the other big players are doing, they're adding these capabilities. So you're seeing more real-time capabilities in data warehousing systems, and you're seeing more and more analytical capabilities in operational systems. And then everyone offers NoSQL. We thought we were the NoSQL database, but it turns out every single vendor has a NoSQL interface. But despite everyone offering NoSQL, everyone wants SQL. So Cosmos DB from Microsoft is a document database that has a SQL interface, just as an example. Oracle, which is the big kahuna in the database world, offers every single NoSQL interface you could ever want. Every single system is going in this direction, and we need to recognize that as a community. So this is the part where I get to pontificate. What are we going to do as a community and as Cloudera over the next decade? The first one, if you couldn't guess already, is we've got to solve auto resiliency and auto scaling. What that means is every time an outage happens, a customer shouldn't even realize it, and it doesn't matter that hardware failed. After the fact, they can come and swap out the hardware, or if it's in the cloud, then the cloud vendor can deal with it. If HBase is running, HBase is running. And auto scaling, I should be able to go up and down based on the needs of my platform. If I have tremendous query load, I should be able to add capacity. If I need to do compactions, I should be able to add capacity. If I don't, then why pay for it? Self-optimization through AI/ML. I talked about using HBase with machine learning for some other purpose than HBase itself. What about using HBase to do better on its own? Wouldn't it be great if HBase could look at how you're deploying HBase in your specific use case and then decide, based on machine learning algorithms that run on the platform and in other HBase systems around the world, to say, well, those configuration settings should be set differently on region server X, which happens to be one of 300 that you're running or one of 20 that you're running. Because that's the optimal setting for that specific region server. And for that table, it should be Y. And maybe over here, we should do a cluster-wide setting. We've got to apply these technologies to the system itself to simplify it. HBase has to recognize that it lives in a multimodal world. Every single database that's of note is multimodal or heading in that direction. HBase as a core is non-opinionated on what the mode is, other than the fact that it offers a NoSQL interface. We heard in this room prior to this talk was about GeoMesa from the CCRI team. There are talks about Phoenix. These are different modes of operating that sit on the core of HBase. We've got to recognize all of these need to coexist, and we need to make it easier for customers to start at X and then go to Y. And then performance. Everyone always wants faster, cheaper, better. No different here. We've got to do better by our existing customers, which means it's the one place where we want to go and look at, hey, we started with data warehousing. We have a number of customers. Can we do something better for them so they don't have to go to other things? But then as we focus on operational needs, how do we do better than millisecond response times? Because there are use cases that need better response times. How do we avoid occasional cache misses when we have to go at hardware and storage that's not on the box anymore? We've got to figure this out, and we've got to move faster. As a product manager, I talk to a lot of customers, and so user complaints can act as guideposts. Whenever we look at, hey, that's where I want to go in 10 years, how do I get there? And so what are the complaints that I hear most often? HBase is really hard to set up. I really don't want to deploy another cluster. Once it's there, then it's fine adding other use cases, but it's really hard. It's complex to configure and tune. Once I've got it tuned and I've added things, it's not quite working, but I don't want to go back and fix it because it's hard and I don't know where to start. It's not quite multi-tenant. Yeah, you've got a lot of multi-tenancy features and it gives me a lot of power, but I probably haven't heard of half the things that you've done over the last 3 years. And then the other half you don't do enough of. And then it's slow at analytics. One of my other projects that I own, Kudu at Cloudera, started this way. Said HBase is slow at analytics for mutable data. Let's go solve that problem. Part of the HBase community, it's something we're going to have to do better at. And it doesn't scale up. HBase is a scale out paradigm, but we have to recognize that hardware has gotten cheaper, and there's a certain base level of hardware that people want to buy. And you can't tell them, well, yeah, HBase is a scale out paradigm. Just add another node. And the customer's looking at me and saying, well, my nodes cost me $50,000 a piece. And you do terrible using at them. I'm using about $10,000 worth. What do I do with the other $40,000? I can't go and ask for another node until you consume this whole thing. So not scale up in the sense of, yeah, we got to consume like 90 CPU boxes, but we've got to stay with what is commonly used in terms of scaling up. And so where's Cloudera going to focus? We're going to focus on operational use cases. As a team, there's enough work to be done that if we just did this one thing, we could expand the footprint of HBase tremendously. We're going to focus on integration. There's a lot of things that have come out of the open source community. And when we've tried to do it all within the project, we ended up with something that was reasonable. And HBase permissions model is an example of something that's reasonable. But then when we look at what else has been done, you look at something like Ranger, it's pretty extraordinary what's been done there. Can we do better? And so it turns out, at least as part of the merger with Cloudera, or with Hortonworks, there's already a connector. Like I said, we're already integrated with most of the Hadoop ecosystem. Let's go improve these by a little bit. Let's go make them more first-class citizens in how we position HBase, because by doing so, we're positioning a larger DBMS. And in a DBMS space, like no one talks about and names their different components like we do, because we've got communities around each of these components. Infrastructure as code. We have to do this. And if we don't, you guys would. So we might as well help jumpstart everyone. And then performance. We're going to have to do better. We're going to actually start with the analytical performance. We've got to go beyond a specific limit and say, hey, we can do an order of magnitude better. And that was a challenge I gave to my team of, if we're going to go look at this, I don't want to do 1x, 2x, 2.5x. How can we do things 10x better? And so, but when you're looking at 10x better, that implies specific things have to change. If you live by the constraints of the past, you'll never get there. And so you'll see things coming out of Cloudera that look a little bit different, that require some changes, but hopefully give gains that will help us consolidate across the community. With that, any questions? Yeah, so we have to, so the question for the recording is about scaling up and scaling down and on-prem in the cloud. And the answer is we have to scale down to some level. Now, I don't envision us running on mobile phones anytime soon, even in the next decade. But can we solve the 30 terabyte use case? Can we solve the 100 gigabyte use case? We're going to have to solve that problem. And then in terms of scaling up, there's no limit. But in terms of the cloud, what the cloud is sold as is different from what people use it for. right? When I've spoken to customers about why they're adopting the cloud, not just while employed at Cloudera, but even at companies I've worked at in the past, I've heard two things: cost and agility. And so what is cost? And if you peel back that onion a little bit, what you end up is, do I want to rent a house or buy a house? It's the exact same argument, and the math is actually remarkably similar. Except there's a little bit of hype. I've never been able to rent before. So imagine a world where you grew up and you stayed at home with your parents until you could afford to buy a house. And then you would jump and buy a house. And then suddenly, after decades and generations of this, someone came along and said, I'm willing to rent you a house. Would you like to move out earlier? That's what the cloud did to the IT industry. And so everyone jumped and said, I want this. Now, the largest cloud customers, after being there for over a decade, realized, you know what? My parents' house is actually cheaper. And so some of those took a step back, built their own data centers, said, you know what? We have the skill. We can actually do this reasonably well, and the bill is cheaper. But I can't build it like my parents used to, or my grandparents used to. And it's like a house, right? If you imagine going back in time to the styling that your grandparents preferred, you'd be like, ew. Similarly, we can't build a data center anymore that has all the knobs and manual things that data centers used to have 2 decades ago. And so the new data centers that corporations are building are highly automated. This is where the term private cloud comes from. This is what VMware has been doing. This is what OpenShift has been doing. Let's add all of the capabilities of the cloud, but allow you to do it privately. Now, come to the modern housing market, we have renters and buyers, and they coexist. Now, this is where the analogy breaks down a little bit, because when you look at a corporation, yeah, they're going to rent, but they're also going to buy. That's the hybrid cloud. And so we have to solve for that. And that's something that's a little bit different. And when we talk about the things that I'm talking about on this slide, in terms of the vision, there we go. Nope, one more. Foiled by animation. All of these things apply regardless of the platform. It doesn't matter whether you're renting infrastructure or buying infrastructure. This is the set of capabilities that customers will want. If I have my on-prem cloud or I have my off-prem cloud, I still want to use infrastructure as code. I still want to have resiliency and scaling without having to think about it. The only difference is, do I incur a new bill, or am I already paying for those resources? And then as the cloud model matures, what that really means is the BU and the group is going to have that question even when they're on-prem. Because yes, while the corporation has paid for the capacity, is my group paying for it or not? So these are the type of questions that come up in a cloud world. They don't really change the things that we need to do. As long as we work well and move forward into this world, we'll be well positioned as HBase, regardless of the deployment model. Any other questions? Yeah, so the analytics plan is more the next 2 years rather than the next 10 years. And the goal that the team has is we need to do 10x better in performance. And that's a 2-year plan. We don't have a 10-year plan. We have to get good enough and then focus on the operational things over the next 10 years. And so we're actually looking at what are the things we need to do to step back from what we've done and to get good enough for analytical use cases. So yeah, you'll probably still offload data if you want to do lots and lots of analytics, because frankly, you want a platform that's optimized for it. But for everything else, yeah, you can do it on the platform without having to hit your operational performance. So doing analytics, but then your millisecond latency is jumping to 10 milliseconds because you happen to be under a period of load, that's a bad idea. So maintain the performance guarantees on the operational side, while we add capacity and performance on the analytical side. Happy to have a more detailed discussion offline, though. Any last questions? All right, thank you.